Hi, I'm Vincent Lose, and today I'll be showing you how to spin up and manage RonDB locally using Docker. And being in the nature of manage RonDB, how to use that to increase the replication factor on a live cluster, exchange containers for MySQLDs, and also create a backup. So I'm in the repository RonDB Docker right now, and as you can see, there's a directory called manage RonDB. So we'll have a look at manage RonDB now. And as you can see, there's a Docker compose file, which basically speaks for kind of like a static cluster. But one service of this Docker compose file is the Flask server. And the Flask server is something like a control plane in a sense. And it also has the Docker socket mounted to it, which means that it can essentially spin up containers and also remove containers if it wants to. We also have a Bootstrap MGM container, and that is where the leader of our database orchestration tool lives in, and then essentially understands which desired state it wants, and then also tells the Flask server which containers it needs and which containers it wants to get rid of. So we have a desired state here, the desired state file, which we mount into the Flask server, and which the Flask server then forwards to the NDB agent leader. And looking at the desired state file, so since this is hosted, we as a user can change this on an existing cluster, Docker Compose cluster, and see how the cluster essentially scales up, scales down, or does backups or upgrades or anything. So we're going to have a look at the first desired state here, and most importantly, we can have a look at the active replication factors. So per node group, we're going to have a replication factor of 1. We're going to have these VM types, which are kind of like container types for now for the different services. This won't really make a difference with containers since they're all the same, but technically, if the control plane were in the cloud, we could spin up different VMs here as well. The same for storage. And yes, so we also have these pseudo kind of region and availability zones. In the cloud, these would be real. The Flask server will now just claim, we're in the availability zone, Solomon. Here's the container. Here you go. So we're just going to run this Docker compose up, daemonize this, and then look at the logs of the Flask server. So the basic Docker compose project has already started. I'm the base. And you can already see that the leader NDB agent has asked the Flask server to create these 3 VMs or containers, which it needs to reach the desired state. So we can see it's working towards the desired state. It's already starting the data node on VM X large Solomon 30 gig, which is here. Now the same for starting in MySQLD on large Solomon 15 gig here, and this will just take a tiny bit. And here we're already at the desired state. So now we have a running cluster of managed RonDB essentially, and we can technically just go into one of these containers. This is also where the management server lives, and do a native RonDB command, management client show, and this shows us that the cluster is running. Yes. Okay, so now we'll go to the reconfiguration. We wanted a reconfiguration where we increase the replication factor, exchange MySQLD containers, and create a backup. So let's just increase the replication factor. So active replication factor to 2. We'll create a backup. So we go to single backups and say, right, this is the backup we're going to create. This is going to be created on Docker volume as kind of like a replacement for a bucket, which would be S3, for instance. And then we're going to say, all right, okay, for MySQLDs, we need bigger containers. So we're going to say extra large. And so we'll increase the ID, increment it to 2, and see how it goes. So it's sent over the second desired state here, and it already spun up. So it has to spin up 2 new containers now, one for the additional data node for the second replication factor, and one for the new MySQLD container. And it also has to remove one MySQLD container since it doesn't need the old VM type anymore. So it's already requesting to start the second data node on pseudomon 30, so B1, which is here, this one. And now it's also starting to request the new MySQLD on C58 here. And lastly, in a second, it should also get rid of the large 15 gig pseudomon here, which will just take a second. All right, starting action to discard VMs now here. And we're at the desired state. So here you can see the container is not being used anymore, and we're at the desired state of the second desired state that we have specified. Thanks a lot, that was it, and hope you have fun trying it out, and let us know if you have any questions or any suggestions of what could be done better. Thanks a lot.